Hi there, this is Physics, the chapter on transfer of thermal energy. Lesson 3, Convection. Now in this video lesson, we will deal with the physics concept of how thermal energy is moved from one place to another by convection. Before we start, let's have a look at what will be covered in this lesson. First, convection heat transfer. How does it work? Second, convection happens best in which state? Solid, liquid, or gas? And what are some examples of convection in our daily lives? Now, convection is actually the transfer of thermal energy by means of convection currents in a fluid. Recall that fluid here refers to liquid or gas. And the key point is this. This transfer of energy by convection current in a fluid is due to a difference in density. Okay? This is a very important concept that we will be discussing about a lot in this video. Right, so what does it mean here? Well, there are two examples of convection current given in this diagram. First is the heating of water, which is actually a liquid in a beaker. Now, these two red circular arrows shows examples of convection current that happens in liquid when it is being heated. Okay, the diagrams on the right hand side, however, shows the formation of winds or breezes in the day and night time. This demonstrates the creation of convection currents in gas. Okay, so we'll discuss a little bit more about what exactly happened when a fluid is heated in the next slide. So let's have a look here. Right, so what happens to particles in a fluid when it is heated? Now, I'd like you to take note of this. When we are talking about heating of fluids, we would like to look at it as a group of particles. So for these examples, you have this group of particles inside this particular container. When it receives heat, okay, the molecules or the particles itself, like this, will start to gain kinetic energy and will move faster and further apart. As a result, these particles or molecules will spread out and therefore occupy more volume, right? So the increase in volume is there, however, there is no change in the mass. As a result of this, we know that density decreases. If you can recall the formula for density, it is given by this, mass over volume. Since mass remains constant, but the volume occupied by these particles has increased, well, we know that the density will actually decrease. So recall as well, what happens when density of a fluid or group of fluid decreases? Well, when density decreases, it will actually start to rise. Right, at this point in time, I'd like you to take note that it's the density of the group of fluid that changes, not the density of the individual particles itself. Over the years, I've seen many countless students who mistakenly answered questions on convection by stating that when a fluid is heated, the particles themselves expand, and as a result, the density of its particles decrease. That is wrong. Okay? The idea here is that this group of fluid, which is made up of all these particles, when heated, they will start to move further apart. Right? So when they move further apart, they occupy more volume, and therefore it is the density of this group of fluid that actually decreases. Let us now focus on convection in liquids. Typical questions asked during GCE O and N levels exams is this. Explain how all the water in the pot becomes hot. These are the 4 points which needs to be stated. Okay? First, you have to mention that when the liquid is heated, right at the bottom, the molecules of this particular liquid will gain kinetic energy and then move faster and further apart. This heated liquid expands and becomes less dense and rises upwards. The cooler liquid, being denser, sinks to replace it and in turn gets heated up. This will set up a convection current that will transfer energy to all parts of the liquid until the whole volume of liquid is at thermal equilibrium. Now, notice how also the convection current is drawn for this particular case. Often, we assume that the heating is strongest in the middle of the pot. The heated water will rise and turn clockwise and anti-clockwise at the top. So effectively, there are two convection currents formed in this particular example. Before we move on to the next slide, I would like to point out another error that students often make. When asked to describe how heat is transferred from the flame to water, students often say convection. This is wrong. The heat from the flame passes through the bottom of the pot by conduction, and from the pot to the water just above it, this is also by conduction. Convection only happens between the heated water at the bottom of the pot and the cooler water at the top of the pot. Now let's answer this particular question. Why are heating elements in kettles usually placed at the bottom? Okay, well, the answer to that is basically the same. It follows the same idea, which is we want to place the heating element at the bottom is to heat up the water right at the bottom. When the water at the bottom gets heated up, it expands and becomes less dense, and hence it will rise. Cooler water right at the top will then sink because they are denser. And this motion of this water will create what we call the convection current again. And it is this convection current that will transfer energy or thermal energy from the heater to all parts of the water. Now, let's have a look at convection in gases. The idea is again similar to that of liquid. In short, hot gas, which is less dense, rises, cooler air, which is denser, sinks, and then creating convection current. So we will just need to adjust the explanation to the given problem. Now in this particular case, the air above the candle gets heated and expands. The density of the heated air reduces and therefore it will start to rise. Now cooler air and denser air from the left replaces the hot air over here, causing a convection current to be created in this anti-clockwise direction. Okay, and we often use incense stick or joss-stick to make the convection current visible. The smoke from the stick will actually follow the direction of the convection current. Now, interestingly, convection current can happen on a very big scale. For this example, it can actually happen to produce wind or breeze. There are two types of breeze. First is the land, and the other one is the sea breezes. Now, land and sea breezes are actually convection currents formed over a large part of land and the sea. Now, in the daytime, the land heats up faster than the sea. The air above the land is therefore heated, expands and rises because it is less dense. Cooler air above the sea, which is denser, moves inwards towards the land to replace the warmer air that has moved upwards. This sets up a breeze which we call the sea breeze because the direction of the cool air is coming in from the sea. Okay? What happens at night? Now, at night, the land cools faster than the sea. This would therefore mean that the air above the land is now a lot cooler and denser compared to the air above the sea. The air above the sea is warmer and therefore is less dense, so it will rise. So the cooler air from the land will then move out towards the sea to replace the warm air. This again will then create a convection current that moves in a clockwise direction. So this particular situation at night creates what we call a land breeze. So far, we have discussed about how convection current is formed to heat up fluids, either liquid or gas. Well, can convection current be formed to cool down fluids? Well, you bet it can. Well, this happens in our fridge. How do we cool the inside of a fridge? Well, the small refrigerator here in the diagram cools its contents by convection. Notice that most fridges have their freezing unit at the top, and it is this freezing unit that cools the air at the top. This cool air, which is denser, will then sink. Warmer air from the bottom, which is less dense, will then rises up to replace the cool air. This will therefore set up a convection current inside the fridge, which will then help to contribute to the cooling of the inside of the refrigerator itself. The aircon. The aircon is one of my favorite appliances In fact, if you ask me, I think that the aircon is the best ever human invention of all times. So how does it work? Same idea as the fridge really. Air conditioning unit is always placed at the top of the room, if you noticed. Okay, again, the cold air that comes out from the aircon sinks because it is denser than warm air. So the warm air in the room will then rise because it is less dense to be displaced and replaced by the cold air. Again, this will create a convection current inside the room, which then helps to cool the room down very rapidly. So with that, we come to the end of this video lesson. Before I move out, let's do a quick summary of what we have learned. First, convection, heat transfer. How does convection work? Do remember these key points. It first works by density changes. Recall that hotter fluid expands, becomes less dense and rises, while cooler fluid is more dense. It will sink and this will create convection current. Take note, it is not the particles that expand, but rather the group of particles. Convection happens best in which state? Well, as you have seen some of the examples, this only happens in fluid, either liquid or gas, not possible in solid. And to recall some of the examples that we have discussed, like heating of water in kettles, formation of land and sea breezes, and also that for cooling purposes in the fridge, like the fridge or the air conditioning unit. Right? With that, thank you so much.